Hello and welcome to lesson 2.3 for Math 111. In this lesson, we're going to continue working with these rational expressions or big fractions. And we already understand how to simplify some of these, but there comes a time when we may need a little bit more skill to simplify them. I'm talking about when we have what's called complex fractions. Well, what are complex fractions? That's when you have fractions inside your fractions. Fractions inside of fractions. And that sounds, if you're someone who hates fractions, like a nightmare. And they look like nightmares. And likely, or I guess in a very positive thing, this is considered not proper. So even if you're someone who loves fractions and you want to make it rain fractions and have fractions inside your fractions all over the place, it's not allowed for you to leave them this way. It's not mathematically proper. So we have to be able to fix or simplify when we have fractions inside of fractions or complex fractions. So let's just dive through a few examples to talk about how we're going to go about getting these things fixed. The first thing we're going to look at is when we have fractions inside our fractions like this. So we'll say we have 2x divided by 27y squared divided by a big fraction bar, 6x squared divided by 9. And there may be some things we could do before we dive too deeply into this one, but one thing I want to point out is I have a fraction inside my fraction. I have a fraction on top of a fraction and a fraction on the bottom. And so this is kind of the first place we look the simplest one to handle. When we have a little fraction on top of a little fraction, we like to treat this big fraction bar like a division. All of them we could think of as divisions. But if I were to write this in another way, you would already instantaneously probably see what we could do to make this not a fraction inside a fraction. If I treated that big fraction bar as a division and wrote it this way, you would say, oh, well, that's stupid. Let's not even write it like a big fraction divided by a fraction divided by a fraction. Let's make this division into multiplying by the reciprocal, by the flip, because that's a trick or something we've already discussed, where you leave the first fraction alone and you say this second fraction, we can turn this into multiplying by the flip and flip it. Put the 9 on top and the 6x squared on the bottom. And then this is just straight up fraction multiplication, so I can put stuff together. Let's see, 2 times 9 is 18, and there's an x on the bottom. Oh, I don't know, 27 times 6 off the top of my head, but we can easily grab a calculator. Here's our calculator. What is it? 27 times 6, boom, 162. 162, and there is a y squared and an x squared. Okay, let's get that box out of the way. All right, we did the job of getting it to look like a normal fraction, but now I have things I want to simplify. Well, the first obvious thing to me is I see x here and x squared, so this x can cancel with one of these. So I know on the bottom I'll have y squared x, or x y squared. Technically, alphabetical order is more proper, although you don't have to write it that way. X y squared, that's more proper. We'll write it that way. Now what about this 18 over 162 business? We need to see if we can simplify this down. Does this reduce any? Well, I know they're both even, so it surely reduces there. Let's bring back up our calculator and see. I wonder, you know what I may do is I may show you an online calculator that's a free online calculator. Let's go with Desmos calculator. Desmos has some great online calculators. Let's see, scientific calculator, that'll work. They have graphing calculators and stuff. And let's see if this will reduce our fraction for us. So what was it? 18 over 162. Oops, wrong button. So 18 divided by 162. All right, so that's definitely a decimal, but look, it has this button right here to convert our answer to a fraction. So let's do that. Boom. Oh, and the reduced fraction of this is 1/9. Beautiful. I love this Desmos calculator and the graphing calculator. I'll show you that later when we do graphing. Desmos has free calculators that are pretty awesome to use. Since this is an online class, you may just be doing all this work on your computer, and so having a calculator right there on your computer would be nice. That works beautifully like this. So 1/9. All right, let's minimize that. Get rid of that calculator. And so instead of 18 over 162, I can reduce that to 1 over 9. And I still have this x and y squared. So we made this messy, messy fraction look a lot simpler. Let me get rid of this right here. It looks a lot better now, doesn't it? So we've simplified it. All right. Now let's go to another type. So anytime you have a fraction divided by a fraction, a big fraction bar, just treat it like a division, turn it into a multiplication, and flip that second fraction. What if I have one that has little baby fractions inside it that are being added? Here's what I mean. Like x over y squared plus 1 over y divided by y over x squared plus 1 over x. Ugh. This looks messy, and if you hate fractions, there's 4 fractions inside of my fraction. Oh, well, wait a second. If I could add these fractions together on the top and bottom, wouldn't it be just like this one with a big fraction divided by a fraction? Where I could do the division trick? Well, let's work on that. So let's look at just the top for now. Just the numerator. Do these two fractions, can I add them right now? Do they have the same denominator? No, they don't. But we know how to deal with this. This denominator is y squared. This denominator is y. Is there anything I could multiply this bottom by to make it y squared? The answer is yeah. If I multiply by y, that would make this y squared. They would be the same denominators, and I could add them together. Problem, I can't just multiply the denominator. I need to multiply the numerator as well. Okay, so let's see. What will I have? I will have x over y squared plus y over y squared. They are now the same denominator. They now can be added together, and I'll have y squared on the bottom, and up top I'll have x plus y. Okay, so this is like just doing the denominators like our last lesson, isn't it? So you see this is building quite nicely. So this is just like last lesson. Now let's do the same thing in the denominator on the bottom. This has an x squared, this has an x. So it needs another x to become x squared. I'll have to multiply by x over x. Let's see, so y over x squared. What will this become? X over x squared plus x over x squared. Oh, look, now they have the same denominator. I know it will be an x squared on the bottom, and I will have y plus x. All right, so what we have done is used our lesson from last time of adding fractions, and we did that on the top, and we did that on the bottom, and now we have turned it in. If I flip back exactly into one of these problems, we'll just treat this as a division. Treat this big green fraction bar as a division, and we will keep the first fraction the same, x plus y over y squared. We will change our division to a multiplication and flip the second fraction. So y plus x is on the top. We're going to put it on the bottom here, y plus x. And x squared is on the bottom. We'll put it on the top. We'll change that division into a multiplication. All right, awesome. So if we go and do what we've been doing, we can just now stick these things beside each other. And we need to see if anything will cancel. I have a question for you. Do you see it? X plus y and y plus x. Are they the same thing? Well, yeah, because I can add in any order and they're both positive. So if I flip these and make it x plus y, that's the same thing as y plus x. So these two factors are the same. And so I'm lucky enough that I have some stuff canceling out or dividing out to 1. Well, what am I left with up top? Just x squared. What am I left with on the bottom? Just y squared. And that is much nicer and simpler. Beautiful. So this is building skills nicely. This is from last lesson, and this is what we've learned in today's lesson. Okay, that's not too crazily difficult. Let's do 1 or 2 more. That's about as nasty and as hard as we're going to make it. Let's do 2 more examples. What if I did one like this? 12x over x plus 5, big fraction bar, 4 over x plus 5. Well, that's just a fraction, big fraction bar fraction. That's kind of today's main point. We already know how to handle that. We're going to take the first fraction, and we're going to treat it like a division. And so how do we do divisions? We turn this division into a multiplication and flip the second one. X plus 5 over 4. So I flipped the second one. Okay. Well, now we're just doing a multiplication, and multiplying fractions is easy. I have 12x times x plus 5 on the top, and on the bottom I have x plus 5 times 4. Oh, aren't we so lucky? X plus 5 and x plus 5, they're gone. And I have 12x over 4. Am I finished? Uh-oh, I think this reduces even more. Look, I have 4 and 12. I know that reduces because I can think of 12 as 3 times 4. And then the 4's will divide out. And I've simplified this all the way down to just 3x. That's pretty nice. One last example, and then I'll turn you loose to try these homeworks. And like I said, this looks intimidating, but when you take your time and think through it and logic through it, it's not that bad. Don't be intimidated by it. That's most people's problem here, is they get intimidated by it. Let's go with 1 minus 16 over x squared divided by I'm trying to make this work out beautifully. Divided by 10 over x plus 40 over x squared. Okay. Now, this is just like, if I flip back to examples, this one, where we wanted to get common denominators in the top, add them together to make a single fraction. Get common denominators in the bottom, add them together to get a single fraction. Now it's just a fraction divided by a fraction, so turn it into a multiplication. And so we're going to handle this exact same way. So let's look at this one. Well, this one's weird. It's not a fraction, but I could add a 1 on the bottom to make it a fraction. We could always do that. But this has a 1, this has an x squared, so this is going to need an x squared. If I multiply the bottom by x squared, I got to multiply the top by x squared. And let's see what we have now. We will have x squared over x squared minus 16 over x squared. Thankfully, they have the same denominator, so I can combine them. That I will get x squared on the bottom, and I will have x squared minus 16 on top. Okay, so that's just last time's lesson right there. We'll do the same thing on the bottom here. Let's see. So this has x squared, this has x. So this is missing an x, because x times x is x squared. So whatever I do on the multiply on the bottom, I got to multiply the top by. So let's see. That'll be 10x over x squared plus 40 over x squared. Nice. Okay, now they have the same denominator. So I can combine them into the same denominator. I wanted to change the blue. Of x squared. And I will have 10x plus 40. Well, this is looking pretty beautiful to me, pretty simple. I'm going to do my job where I keep the first fraction the same, x squared minus 16 over x squared. I'm going to turn this division into a multiplication and flip the second fraction. So if I flip it, x squared is now on the top, and on the bottom I have 10x plus 40. Okay. I'm out of space. Let me run down here. So I can now put this together in a big fraction where I have x squared minus 16 times x times. That looks like a x squared. On the bottom, I have x squared times 10x plus 40. Ooh, yes. You see the x squareds will cancel out, and I have something pretty simple. I have x squared minus 16 on top and 10x plus 40 on the bottom. Well, this looks great, but to make this kind of the hardest problem, I bet this might factor and simplify more. So let's do our best factoring skills here, and let's see what we get. Well, this is a difference of squares, a subtraction of two perfect squares. And we know what that's going to factor into. That'll be x plus 4 and x minus 4. This one doesn't look like it factors anywhere special, but it does have a greatest common factor. I can factor out a 10. And when I factor out a 10, I'll be left with x plus 4. Oh yeah, some does cancel out more. X plus 4 and x plus 4 are gone. And I have an even simpler expression left. X minus 4 divided by 10. Beautiful. That's about as messy and as difficult as we're going to make it. That's one that required the skill of adding two fractions again, turning this big division into a multiplication, flipping it, simplifying some, factoring some more to simplify. But those are all skills that we have built. We have this skill of adding or subtracting two fractions. We have this skill of flipping and multiplying. And we have this skill of factoring and canceling. So it just took a lot of different skills combined, but we have all those skills. It's not too bad or too scary if you take your time. Well, that's all I have for you. Good luck. Give the homework a try and email me if you need me.